Okay, hey guys, welcome back and let's solve the problem 1894. Okay, find the student that can replace chalk. Okay, so let me just give you the brief introduction what this question is saying. Quite overwhelming in the starting, I'd say quite confusing. So there are three students, one, two, and three. Okay, and I have this much of chalks. Okay, and if a student came for the board, he will use this much amount of chalk to solve a problem. Okay, so it's like a student 0 came, so it will use 5 chalks. Then student 1 came, so it will use 1 chalk. Okay, the student 2 came, it will use 5 chalks. So in total, it would goes like 11. Now this will repeat. Now it was like this moment. Then we will start from again this position. Okay, again 0 came. It will use 5 chalks. 1 came. It will choose 1 chalk. Second game, it will choose 5 chalks. Now it will move to 11. So this becomes 0. So now we have to tell on which student, if he came to the blackboard, the chalk becomes 0. So if we choose the cycle again, we will be like this student will got no chalk to use. So we have to return this number. Okay, so how to do that? So what if I say that like 5, 1, 5? Okay, it's like we can in a brute force we can go uh on this position 5 plus 1 6 plus 5 11, then again we move to 5, then again it's become 22, and then again we move to the 5, it becomes 0. The sum becomes equals to k. Then we can say like, yeah, on this position we will return the answer. But this is not so fruitful to use because we are keep on looping and looping and looping and again and again. So what if I calculated the sum of total array? So it will be like, yeah, it's 11. Okay. Now what I will do is I know that if there is some x value, and if I do a cycle, then it will minus 11 out of this. If I do the another cycle, it will again minus 11. If I did again, it will become minus 11. Now, suppose it is 50. Okay, minus 11, some y value, minus 11, some z value, x value, minus 11, some value. Now, this value should be lesser than 11, and we can't minus that. Okay, so like 23. Okay, suppose this is 23. Is the number of jobs. I minus 11. So it's bigger. 30, 12. Now again, I minus this. So it became 1. Now I move 2 cycles. 1 cycle, 2 cycle. And on the third cycle, I have only 1 chalk left. Okay. So instead of choosing repeatedly this position, I can simply use 23 mod 11 and it will give me 1. Okay, now just use the brain why I'm using the mod here. Okay, and what this mod is doing. Now suppose I have 6, and if I mod 2 with this, it will give me 0 because cycle is going to be in the loop and it will consume all the values. Now, if I have 5 value and if I mod 2, it will give me a remainder 1. This is the remainder. Now, with this job, I can iterate over the array and see how many students can use this. And if any user is not using, then we can return the index. Okay, understood? So, first point, find the total sum. Okay, now second, on which index the chalk becomes 0. Okay, for this, I can just simply iterate over the array, but there is some good approach. And what is that? So in first step, I have to choose total sum. Okay, so what if I do a prefix in this? So it's like the array was 5, 1, 5. Let me convert this into 5, 6, and 11. Means if I'm standing here, I will consume 6 from the 0 index. And if I'm standing here, from the 0 index, I will consume 11 in chalk. Okay, now suppose, now this will give me the total sum, okay, which is this one. And if my array is something like, uh, let me increase something like this. And after all the remainder, my k comes like 7 chalks. Okay, so then I can simply do a binary search in this and see where my 7 lies. I will say like here, my 7 would lie here. So I would simply return the next value. Means on this student, my chalks will be lesser than the consumption. Okay, got my point? So let's code this. So let's find the length of the chalk. So let's convert this into okay, now for I in range 1 to n, nums I equals to nums I minus 1 plus nums I. Okay, now here I created the prefix array. Okay, now thing starts here. Now how many chalks I will use in whole cycle? It would be like total use equals to nums minus 1 last index. Okay, of the prefix array. Now, if my total use is less than equals to k, there could be one situation, or if my total use is greater than k. Okay, so suppose like if my array sum is more than 22, okay, there could be like something like that, or there could be like the k total use is 11, so it would be like in this case. Okay, now suppose if my total use is greater than the k, so then I have to simply binary search over this array. Now suppose I have something like 5, 6, 11, 80, and 20. Okay, and my total chalks is only 6 that I have. I can simply binary search over here this array. So I would like, yeah, I just move here. So I will return this. Okay. So for that, I will just use index equals to bisect dot bisect left Go to okay, okay, return and perfect. Now, what if my total use is less than? So I have to mod this. So it would be like k equals to k total use. So this will give me some remainder. Then I will use this. But in this I will use plus one because in this I have to give an extra index. Perfect. Now there could be a solution where index lies here. Where index lies here. So I will give return to 0. If index equals to n, return 0. Let's submit this. Yeah. So this condition, if my total use or yeah, total use is greater than the total jobs I have. Okay. And in this, if I will use the cycle concept, in this, there will be no cycle. So one iteration and check. Okay. Hope you understand this concept. If you do, just give it a like and subscribe. And the time complexity would be like O of n plus binary thing, log n. And space be like, if I'm choosing this, maybe not O of 1, yeah, like that. If I'm not considering this as a space, so okay. So hope you understand this concept. If you do this, do it like and subscribe, and then see you. Bye bye.